to this channel. In this video, we will continue with the chemical properties of amino acids. Because of amino acids consists of both carboxyl and amino group, so that's why we can see some of the chemical properties of carboxyl and amino are in this chapter. And then next, we are going to discuss about the peptide group. Okay, let's start with the chemical properties of amino acid. So like just now we mentioned that amino acid consists of both acidic and also the basic functional group. So they will undergo two main types of chemical reaction. First one is the one that will react with the amino group, which is with the HCl, because HCl is the acid, so acid always can react with the base. Another one is the nitrous acid, which basically is prepared in situ from the sodium nitrite with the HCl. So second reaction will focus on the carboxyl group. So also we will continue with two reactions. First one is react with the NaOH, and second is react with the alcohol with the presence of acid to form ester. Okay, reaction of amino group with the HCl, hydrochloric acid. So acid and base react, basically they will form a salt. So let's look at the equation. So start with the general equation. Let's say we have the amino group and also the carboxyl group, but only the amino group will react with the HCl and end up they will form NH3 plus Cl minus. So another equation over here, still the same case happen. We just focus on the NH2, and you will notice that once the amino acid react with the HCl, the NH2 will become NH3 plus Cl minus. So just to get in mind that the positive charge belongs to the nitrogen. So you can put the positive charge at the left hand side or right hand side of the nitrogen. Okay, now the amino group also can react with the nitrous acid. As we know previously, nitrous acid have to prepare in situ from sodium nitrite and also HCl. So the amino acid group also need to react at the 0 to 5 degrees Celsius, as we learned in chapter amine. So that since the amino group is the primary amide, so they will always form the diazonium salt as the intermediate. Okay, but because of it is the aliphatic, so they will lose the nitrogen very quickly to form the carboxyl ion and also release the nitrogen gas. So the carboxyl ion then will undergo will react with the nucleophile to form alcohol, alkene, haloalkanes. These are the three main organic compounds. So now let's look at one example over here. Okay, this is the example that we are going through. So this is the general structure formula for the amino acid. React with the nitrous acid at 0 degrees Celsius, or you can put 0 to 5 degrees Celsius also can be accepted. And then the NH2 will be taken out, will become the diazonium salt. And this diazonium salt is unstable because it is from the primary or aliphatic. So by removing this, it will remove the nitrogen gas, and where we can see there is bubbles of gas, which is similar with what we learned in chapter amide. Primary aliphatic amide will release nitrogen gas, and then it will become carboxyl ion, and where will react with the nucleophile to form alcohol, attached to the hydroxy group, or haloalkane to attach with the halogen, and then we'll remove the hydrogen. So basically, we will remove the hydrogen from the alkyl group. Okay, so and then the side product is the HCl. Okay, now let's look at the part of the carboxyl group. So the carboxyl group able to react with the sodium hydroxide, and where the sodium hydroxide act as the base and carboxyl group act as the acid. So since it is acid and base reaction, so we're going to produce salt as well. But this time for the acid, we know that as the definition of acid is will produce H plus. So means that the bond will break between O and H. So and then for the NaOH, for sure is Na plus and OH negative. So the Na plus will attract to the O to form O negative Na plus. So another example over here, also the same case. The OH group will break the bond and become O negative and attracted to the Na plus. So these are the part that we have to alert. The hydrogen will be taken out and replaced with the O negative, Na plus. Another reaction that always carried out by carboxyl group is react with the alcohol to form ester. So do remember that the esterification need an acid as the catalyst. Normally we use HCl, but sometimes we also can use H2SO4. So look at here the general equation over here. For the carboxylic acid, we are going to taken out the OH this time, and for the alcohol, we are going to taken out the hydrogen. So this is the case that will be happen. So the H and OH, which combine together, will become H2O. And then where the bond break, we just connect back. So the bond is break between O and H. So the O will connect to the carbon. So now look at one more example. If you are given the exact structure over here with the structure of the alcohol and carboxylic acid, so please look at here. We will take out the OH from carboxylic acid, H from the alcohol to form water, and then the O will connect from the alcohol will connect with the carbon. So this is how we're going to write the equation. Okay, continue with the tutorial question number 7. The structural formula of threonine 2-amino 3-hydroxy butanoic acid is given below, and then now they are going to react with the NaOH. So we know NaOH is the base, so basically it will react with the carboxyl group, okay, or the acid. So from this question, we notice that there are two acids. One is NaOH, and then another acid group is the COOH. But then NaOH, if you still remember in the topic here, NaOH only will react with phenol and also carboxylic acid. So therefore, the OH will not react with the NaOH. Because of this, so the product form for structure A will become NH2 10 because amino group is base, will not react with NaOH, CH 10, C double bond O will become OH will become O negative Na plus, and then here we have C H CH3. The OH is not strong enough to react with the NaOH, so we'll maintain as OH. So this is answer for A. So next one, we are going to react the threonine with the HCl. So HCl is the acid, so they will going to react with the base. In this case is the amino group. Okay, so this is the amino group. So this amino group will become NH3 plus then Cl minus. Since we want to show that the nitrogen will be bonded to the carbon, so we will put the nitrogen at the right hand side, connect to CH, and then the COOH going to maintain, and then same case we have CH, CH3, and maintain the hydroxyl group because the hydroxyl will not react with the acid. Okay, then now next one we are having the methanol in the presence of concentrated H2SO4 reflux, which is mean this is going to produce ester. So ester will amino group, the hydroxyl group will going to react with the carboxyl group. So NH2 maintain, CH maintain, CH3OH maintain, and then the COO negative will become C double bond OO, because we know that for the carboxyl group it will taken out the OH, and then for the alcohol it will break between O and H. So and then the bond will bonded to the oxygen CH3. So these are the product of the ester form. Okay, we still have one more question in chapter question 7. D, NaNO2 HCl means that this is the nitrous acid. So nitrous acid will be going react with the amino group. So from here we will start from the amino group. As we know, they will produce the alcohol. So we can replace the NH2 with the OH, and then CH, C double bond O, OH, and then C, CH3, H, and also OH. This is the first structure. And then we also have the mixture. Now we will change the NH2 become the Cl, CH, C double bond O, OH. The rest will maintain the same CH3, H, and OH. Okay, so this is one structure, and then here another structure. So the third one will be the alkene. So we already removed, so the carboxyl ion will be here. Then we are going to remove this hydrogen so that to form the double bond. So the third structure will be CH, and then double bond CH3 OH, and then connected with the C double bond O OH. So this is the third structure that will be formed. Question number 8. In previous video, we already draw the structure of the isoleucine and then draw the structure at pH equal to 2, 12, and Pi. So today we are going to start with here. If the product form when isoleucine react with ethanol in the presence of HCl as the catalyst. So from here we know that this will form ester. So the name of this reaction will known as esterification. So let's start with the structure of pentanol acid. We have 5 carbon, and then second carbon NH2 amino group. Third carbon we have CH3, and then now here CH3, CH2, CH, and CH. Okay, so then we'll react with the ethanol. Let's say the ethanol with CH3, CH2, OH. We use the green color one. For the carboxylic acid, we'll taken out the OH, while for the alcohol, we'll take out the H. So end up, the product will be CH3, CH2, CH, CH, C double bond O, O. Okay, sorry, the O here is from the alcohol, so we'll use the green color one, O, CH2, CH3. Don't forget the structure. Here we still have the substituent CH3, and then we have this substituent and H2. So this NH2 is the base. So this base will able to react with the HCl. Therefore, the NH2 will become NH3 plus Cl minus. So this is the structure of the product formed after react with ethanol in the presence of HCl. Okay, next one we need to learn about the peptide bond. So basically the peptide bond will be formed when two amino acid react by eliminate one water molecule. So the compound form will known as dipeptide. Okay, and then the bond that linkage will known as peptide bond. So now this kind of reaction also can consider as condensation. So basically the meaning of condensation here is means combine two product combine two molecule by eliminate a small molecule. Okay, so peptide are amino acid polymer which the individual amino acid are linked together, and then this kind of bond we will known as peptide bond. So example, we always will draw the amino group at the left hand side and the carboxyl group at the right hand side. Okay, when this happens, when we have two amino acid, so you will always remove the OH from the carboxyl group and the H from the amino group to form a dipeptide. Okay, so this dipeptide will consist of the peptide bond. Okay, before we go in, so want to highlight again. This whole compound over here will be known as dipeptide. Okay, but the bond here, the linkage in between the C double bond O and NH will known as peptide bond. Okay, so if you want to specify, this is the peptide bond. Okay, in this slide we're going to learn how to form tripeptide. So just now, dipeptide means we combine two amino acids. If tripeptide means we're going to compare three amino acids. So just want to highlight over here. Just now we also emphasize that for the amino group, try to always write it at the left hand side. And for the carboxyl group, always write it at the right hand side. So that will be easier for you to form the peptide bond. So for example, now after already arranged, left hand side is the amino and right hand side is the carboxyl group. So the OH will be taken out and also the H from the amino group. And this one also will happen. Okay, so once we combine together, so the C double bond will bonded. So this is peptide bond. Okay, and this as well also is the peptide bond. So a tripeptide bond generally will have two peptide bonds, while a dipeptide bond, a tripeptide always will have one peptide bond. Okay, so I think we already finished the chapter of the amino acid. So in next video, we will going to discuss the objective question in the tutorial. See you in next video. Bye bye.